Hello guys, welcome back to digital electronics lecture. In today's session, we'll be talking about inverting inputs of the logic gates. Earlier in the same chapter, we talked about inverting the output side of the logic gates, but today we will be talking about inverting inputs. So basically, we are doing the same thing. Our goal is to generate another different logic gate, or just to step ahead, we'll be discussing De Morgan's theorem. We will talk about that later on, maybe in next few lectures. But today we will just have a idea how can we invert inputs. Okay, we will go ahead and do some examples. Let's say we have example number 1. For instance, we have a 2 input AND gates. We call it AND2, input A and input B. And as usual, we call our output Y, or you can call it C, whatever. So we call it AND2. So that means an AND gate with 2 inputs. So our goal is to invert the inputs. So that means we have to add inverter to both sides of the to both the inputs. So we will redraw that logic gate. So that's my inverter for the A input. Okay, and I'll redraw that logic gate. Alrighty, so instead of N2, I'll write A2, output Y, A, B. So basically this is the inverter, so I have to add that inverter to both inputs. So what will be our new logic gate will be, we'll have to find that out, see how that goes. Let's redraw that logic gate with a new diagram. So we have a AND, we have previously AND gate, that will be no more AND gate. We have that input which is inverted right here. We have that input B inverted right here. So we have A and B inputs inverted. We have our output Y. So you see this was AND2, but this guy is not AND2. This is a different gate. We will see if you draw that truth table for that. This is a truth table for AND2. So the output is only high when both inputs are high. But this is a totally different logic gate, and we will talk about how we know what logic gate is that. We will know from the expression from two way. One will be the De Morgan's theorem, and the other one is we have to physically see what is or where the inverter is being used. Since we have the inverter or the bubble in front or the input side of the logic gate, we will automatically know that what gate is that. In this case, since it's an AND gate and it's inverted in the input side, this will become NOR gate or NOR 2. So that will be our NOR gate here. So that will be not B not. We can call it NOR 2. Truth table for this NOR 2 and this logic gate will be exactly the same. So it only came in when we add 2 inverters to both sides of the inputs, and that will be our new generated logic gate. It's NOR 2. So this is it requires a little bit a Boolean algebras map. Just to give you guys a heads up. This, okay, let's try to do some math here. So this logic gate was A naught. Since it's already AND structure and B naught is equal to Y, if we study the theorem of De Morgan's theorem, we have a condition that if we have A naught, B naught, you can write it down, A naught, B naught, A, B, all night, not all night, the whole or just a whole bar, or together it's not. We have a law that we can write down this as A plus B naught. We say like A naught plus, but we A or B and all together is not. So we know this is an OR gate, but this is inverted. A or B not. So that means it is NOR gate because the whole parentheses has a inverted sign. So A or B are inverted, and we have a NOR gate of A and also B. So that will be, there we go, A or B. Let's redraw this. A nor B. We call it A nor B equal to Y. So that is our new logic gate after we added two inverters to the input side of a AND gate. Don't worry about these Boolean expressions. Right now we will talk about these things later on, but right now we will just have to focus on how to invert these inputs of a logic gates. Okay, that was one example. Let's move on to example number 2. When we add example number 2, when we add an inverter to the gate that we just created. So let's say inverter, we have two inverter because we will be using the same exact gate that we created. We will add these two inverters to the NOR gate that we just created. We will still call it Y, the output. That's a NOR 2 gate, or NOR 2 means there's a NOR logic gate with two inputs, input A, input B. So what will be our output in this case? So pause this video please and figure out how can we reverse engineer this thing. Okay, I think you probably should know this because we started from the AND gate from the previous example. We added two inverters and we created this NOR 2 gate. Now we're reversing that process. We are adding again two inverters to the input side of the NOR gate that we previously created in another example. So that if you guessed, the AND2 gate is our new gate, the new logic gate. So you are right. Our new logic gate will be AND2 gate. So that will be our new logic gate. Okay, so that was pretty simple. Now if we will probably have to do one more example and then we will carry on to the next lecture. Let's do one example number 3, where we said we have two inputs has to be inverted, and the logic gate we will choose will be, let's use a OR gate. So we will add two inverters and to the OR gate. So this is OR gate. I'm sorry, my drawing is not that perfect. It's not even, that looks ugly. That's better. Input A, input B. We can call that OR2 or OR gate with two inputs. When we invert these two inputs from of the OR2 gate, our output will be what? Output will be, we can go ahead and here check this one. We added two inverters and we inverted both of the inputs to the NOR gate, and we got our new logic gate was AND2. So if you guess the new logic gate is a NAND gate, your guess is perfectly right. So if your inverters are added to the input side of the OR2 gate or any OR gate, your new output will be NAND gate. Your new logic gate will be a NAND gate, a NAND 2 gate. Okay, that was not that bad. It was actually pretty simple too. Okay, I will need you guys to reverse this thing. I will want you guys to add two inverters. Please do this. Please do this exercise or do this example where you add two inverters to both input and tell me two inputs of the NAND 2 gate and redraw the new logic gate. Please follow this previous two examples. We created a new logic gate here by using two inverters to the input side of the OR2 gate, and please do the exact same thing and add two inverters to to this logic NAND 2 gate and see what our output looks like. Until then, take care guys. I'll see you with next lecture.